Hello, I would like to present program Metalography, which can be launched by icon setting on surface of Windows. 2 times click with left push button on mouse on this icon. We are subsequently asked to set a trans password of the program. User can change this password at any moment. After this will show main screen of program on which you see the menu. On the left down is maker's emblem. Clicking on logo will show information about authors. It is his email by which you can communicate it with him. Onward, we are step-by-step activate items of this menu. As the first, we choose item Microstructure by types or mark of materials. After activation at the upper bar, 2 offerings are shown up. The first offering shows that the materials are integrated into groups and every group has yet subgroup. E.g., we choose first item from offerings, steel and materials based on Fe, and on subgroup, case hardening steel. Onward, we can choose information source, choose the second item. Subsequently, will show offer towards our selection. From this we choose surface hardened by hard, gathering rock bit parts. These 2 are using in the petroleum and geological industries for drilling hole into the earth. After activation of this item, you see 9 images on the right as a pictorial offer. On the right down, you see push button which question mark, and after its activation, you will learn how to use this pictorial menu. When you want to look up the contents of some little picture from the menu, set the mouse cursor into this little picture and press the left button of the mouse. We can go back by pressing right button of the mouse. For example, set mouse pointer on the first picture of the menu and press left push button of the mouse. You will see contents in this picture. Again, activate by pushing button with question mark and learn that after adjustment of the cursor on the picture and by pressing left button of this picture will enlarge. We can go back by pressing right button of the mouse. So we enlarge this picture. On this picture you see cut cone. Cut elements here are created by teeth. Its surface is furnished with hard weld deposit based on the wolfram carbide. On circle you see holes which are filled with inset of sintered carbide, which helps to maintain the dimension given in this area while drilling. In the center you see microstructure of hard buttering. His thickness is around 1.8 millimeters. You see here bigger and smaller wolfram carbides set in the matrix. Hard buttering isn't completely uniform. On the right picture you see that the buttering was laid on carbide surface. As part of carbides is rounded off, smaller carbides dissolved, and on its place rise Lebedev structure. It's good to see on this picture. In locally A and B can be C last stage melting of carbides. At point where carbides dissolved, rise Lebedev structure. Along here you see reaction between matrix and tungsten carbide. It is better seen on the next picture where it's clear that locally where dissolved carbide come into being Lebedev structure. Next effect which occur by the hard surfacing is diffusion elements in base material. Elements from hard surfacing diffuse into base material on frontiers original grains of austenite. Next we look how hard surfacing. These were to be made on samples 30 x 70 millimeters. Hard surfacing were to be made by the 2 types stamped, namely Durite A and H2. On the left picture you see weld deposit made by stamp Durite A. Stamp consisted from the tube which is filled with dust from tungsten carbide granules. By the hard surfacing with flame steam dissolved and weld deposit tip over granules tungsten carbides. In here you see that some carbides completely dissolved, what's effect of high temperature hard surfacing. or long-time hard surfacing, and next is the reaction between carbide and matrix. Better to see for the next picture, the reaction between carbides and matrix show as white border around carbide. It can be seen here to fill tungsten carbides as effect temperature of hard surfacing. Also documents hardness of carbide, which considerably be high, 1600 Vickersov against hardness of matrix. Next, you can look how looks incorrect Hartley buttering. On left microstructure can be seen well deposit which is made by high temperature. All carbides dissolved, only near to surface sample state, some carbides because here was lower temperature. On the central microstructure, the weld deposit was made by slack dried stem. Integrity weld deposit is corrupted by oxide inclusions. On the right microstructures, weld deposit was made on dirty surface. Weld deposit is completely corrupt, disruption to his integrity, which cracks and pour. After we can show net of cementite, which come into being by incorrect controlled process of carburize. As you can see, cementite segregate on original frontiers grains of austenite. They are then very stiff and it frequently causes the material failure. It is better see on the right picture. Next we show how it is set cut cone on arm of rock bit. On Journal of Arms, the cone is set on 3 beds. Radial bed is for 1/3 circuit bedded with hard metal based on cobalt. The rest 1/3 function as tank of lubricant. Lower you see spherical track to which insert balls through technological hole, and after closing this hole displacing non-reversible. The last is actual bearing, which here no good seen. Now we shall be devote on hard weld on the surface of radial bed. Hard weld has hedendric structure. Orientation of hedendric its gradients of temperatures. Base material has a ferrite paralytic structure. On right picture is state after heat treatment, base material has biotic structure. Weld deposit is after heat treatment solid. Show how oneself be searching for microstructure when we know marking of material. We can look on the second material. This is the aluminum bronze. Up is triplet picture offer. On left picture is dendrite structure after homogenization. They are oriented at the direction of mechanical working. On the second picture show new grains after recrystallization. Structures have martenized morphology. On the last picture is documented growth, new grains. These generally come into being on boundary line join of 3 grains. Now show as you can search microstructure when you know chemical composition of the material. Make active item microstructure by chemical composition. Subsequently, it needs choose by how many elements we shall be search. Choose item, locate structure by selections, 1 or more element. Here you see table in which assign contents of elements. We know that wanted steel includes 10% of chromium and 2% of carbon. So activated column for chromium and selection from menus required content of this element, and in like manner this meant to with carbon. Done, you see the table with result. Chose axle bed. On the left is surface of central selection cone. This has an after circuit teeth, but is stepped with insertion from sintered carbide. This is fixed into holes. In the center is set axle bearing. His microstructure can be seen in the center of the picture. Carbides are orientated into row in the axis direction. In the right picture is structure of worn down bed. On surface is crumbling flake and onward is carbide's orientation changed into direction of load, so into rotation direction of cone. After activate these items will show number of alphanumeric symbols, searching information about coating. This is sign. On the left picture is microstructure of coating tool steel. Layer of TIN is coarse 1 to 3 micron and it's uniform. Coating was made with PVD technology, so under temperature above 400 Celsius. In the center is coating on the other tool steel. Layer tin is an uniform and somewhere is missing. Coating was made with PVD technology. On the left you see coating cutting blade from sintered carbide. Coating is here combined. Thickness of coatings is about 42 to 5 micron. Coating was made with CVD technology, so at a temperature about 800 Celsius. Measure thickness of coat on the surface of cross section after metallographic preparation is greatly laborious and not exact. On this picture you see more easily manner measuring of thickness coating. In the holder is fixture coating tool. Steel ball rotates by disc powered by small power motor into places where contact ball with coating surface adding diamond paste. After several minutes create foot on coating surface which evaluate under microscope. Measuring inner D2 and outer D1 dimension of footstep. Diameter of ball D we know and by formula calculate thickness of coat. On the left picture you see arrangement tools in the chamber of devices. Tools rotate around axis of chambers as well as around axis of preparation. Such tools motion be needed for searching uniformity of coat. Device has hollow cathode which is set on chamber door and in here her haven't seen. Against cathode is anode from copper block and in the center is titanium cubicle. Up of anode is blind. After starter arch argon forced over by hollow cathode ionized and heavy ions of argon bombard to surface, but it also to all chamber. Between chamber and anode is electric potential, so ion and of argon are accelerated. By this process, tools cleaned as well as heated. After temperature reach 400 to 450 Celsius, the blind remove aside and over this stem blooming in chamber nitrogen. Ion of nitrogen react with ion of titan and be formed composition TIN which migrate on two surface and all lower chambers. The start of process of coating. After 30 to 40 minutes create coat TIN on surface tools about thickness 2 to 3 micron. On other picture you see different arrangement tool and this coating. In this case you see massive form which see on this picture. Here's problem with heating molds where upon are on her heating applied cooker which were placed on blind up a note. This is bind. After closing chamber start heating which may be take to several clock because it is deep vacuum and heating takes place only by radiation. After heating will remove cooker and start process of cleaning and coating. The results you see on the right picture. Next activate item reagent. At the upper bar you will show offer from which selected reagent for iron and steel. From menu select reagent for microscopic examinations, Next will show list of most widely used etching agent, for example culling reagent. Reagent nonmetallic inclusions, hydrogen peroxide and sodium hydroxide. Or you can see general reagents for iron and steel. On the list will show two known etching agents, nickel or picral. Which suspension used for slurry etch attack polishing? On magnesium, use such solution. On titanium, which is very tenacious, use several solutions. On chemical polishing, iron are using this solution. This was demonstration review various reagents on calling microstructure for different methods. Show how user may add microstructure in program. His own microstructure. Before activate this item, we demonstrate where must be saved images of microstructure which you wanted insert into program. Find directory where it saved this program. Usually it is in directory program files. You see that in this directory already include such images away from 1 on 12. These 12 picture user may insert into databases of program. Size of picture you can find by open one from these images. In this editor, you learn width and height of picture and his resolution. Now activate item Add microstructures by users. Our microstructure belongs to group of heat resistant and refractory alloys and further refractory metals and alloys. Don't enter chemical composition. Here down see you have available 12 images. Choose item, put picture. From menu select 3 pictures plus text. Subsequently will show organization of 3 images. In each of reserved seating, insert picture from left down menu. Step by step put picture 1 up to 3 and after agreed placement, picture put text. You can write text to there be pictures and to write chemical composition. When it's all right, press Ctrl W and close editor. Finally, put the mouse pointer inside any picture and press right push button. Now can we add these 3 images into databases. Now after activation items, user-defined microstructures will show offer at the upper left. Looking for a structure, they are set in groups of heat-resistible and refractory alloys and refractory metals and alloys. We can see only 3 pictures, but we can see there is no text. The upload wasn't done correctly, but we can make the correction here. As you can see, we can write into the text, we can save it, and as you can see, everything is correctly done now. By this, we would completed examination of the program. I would like to thank you for your attention. This program considerably helped to those who seriously deal with metallography, as well as help students who would like to get some kind of orientation in this field. Where true and that you may add and preserve custom microstructure, this program become a tool near different presentations. The one who would have interest communicate with the author is here cited his email address or may visit page www.postmetal.sk where learn more about this program. So thank you again for your attention and have a good time.